Good. So in the previous session, we were talking about the performance measurement or the performance evaluation of computer. Then we talked about performance evaluation of CPU. So today we try to talk about the performance evaluation of instructions for any given program. So the question arises that is every instruction in a given program is same in the performance evaluation means? That means, could we assume that the number of cycles which are required to execute the instructions like add instructions or the multiplication instruction or floating point instructions or integer instructions or any memory instructions or same means the assumption is incorrect. Why? Because if you look at the sorry, the simulation tool, I hope it's visible, right? Let me just give me a second, please. Okay. Yeah. So if we take this example, so for a simple program, which we discussed, like even in our assignments also, for a simple program like I is equal to 1, n is equal to I multiplied with 2, add p is equal to I plus n. So for this instruction, when it is compiled, the instructions are generated for these programs. Okay, so here in the program, if you find that there is how many lines of program it is, means it's a 6-line program it is, but which is generated these many number of instructions, correct? So the question comes that is every instruction takes the same number of cycles? That means if you look at here, the memory read operation cycles are different, memory write operations are different, there will be a base address, okay? And for execution, it may take, the control instructions, they may take some number of cycles. And for arithmetic instructions, they may take some number of cycles. Okay, so that is depends upon the operation. Depends upon the operation. So that's why one cannot say that every instruction have the same number of cycles. So this assumption will be incorrect. So that means for multiple applications, operations, suppose, they may take more time than the simple addition and subtraction operations. And suppose in that addition or subtraction operation, mathematical operation, if the source operands and destination operands, if they are the floating point numbers, so they may take more time because the conversion is required for floating point, converting integer part into binary, then the floating point into the fraction point into binary, then normalizing that number, then encoding that number using IEEE 754 standard in single precision. That takes more time than the integer operands. Similarly, accessing the memory, that is the accessing the general purpose registers, for example. Let me just share this. Okay, so accessing any number from this general purpose registers may take less time compared to accessing the number from the data memory, from this data memories. So it may take more time. Okay, so that's the difference. So that's why we say that the number of cycles which are required to execute the instructions, that will vary based on the operation and their complexity. Okay, so the changing the cycle time that often changes the number of cycles, as we just discussed in the previous session also. So then what is the standard equation in terms of the instructions in a given program? Okay, so if you look at in this given program, for this simple program which we have just observed, okay, let me just change it. So for this simple program, if you look at the number of instructions, it is the combination of the data transfer instructions, like move the value 1 into the, so that is from this RAM into the general purpose register R0. So that is the memory access time. Okay, so in this, it is having one multiplication operation and one addition operation. They are the arithmetic operations, and there are input output operations are also there. So this simple program is having the combination of data transfer instructions. If you look at the instruction set, it's having the data transfer instructions like move instructions and load instructions, if you observe. Okay, and it's also having the input output instructions like in and out instructions here. It also having the arithmetic instructions like add instruction here, and the multiplication instruction is also there here. So this program is the combination of multiple instruction sets. And then every instruction is not having the same number of cycles for execution. So then it counts that how the clock cycles are executed. So the clock cycles are executed at the number of instructions in a given program. In our previous program, the number of instructions for a program that is multiplied with the average clock cycles per instruction. The average clock cycles per instruction. So if you look at this example, suppose from this, so in this program, if you take the example, the number of instructions, how many instructions are there here? If you start counting here, total how many instructions are there? Can someone help me? Total how many instructions are there? Yeah, good. So total 24 instructions. Correct? So out of 24 instructions, a few instructions are repeatedly having. So assume that for this example, let us assume that this data transfer instruction takes, suppose, 1 cycle, for example. Okay. So how many times this move instruction is appeared? So in our previous lab, we counted that one, the total number of times it appeared. So that gives the average number of total number of move instructions or the load instruction or store byte instruction, that gives the average clock cycles per instruction. So let us assume the average clock cycle per instruction for memory instruction. Let us assume that it's suppose 4 instructions. So out of 24 instruction, if there are suppose 16 instructions or move instruction, they multiplied with 4, that gives the average clock cycles per instruction. So that means the total execution time of CPU is the total number of instructions which are counted here, the instruction count 24 plus per instruction, if it takes 4 cycles, so cycles per instruction, so 24 multiplied with cycles per instruction, and the clock cycle time, if it is in seconds, The time will be in seconds. So that is the CPU execution time. Or we say that the instruction, the performance evaluation of the CPU based on instruction count.